Hi, I am Marian, and in this short demo, I'm walking through a hands-on project I built from scratch, a Shopify style AI backend service built with fast API, containerized with Docker, and manually deployed to AWS before the infrastructure as code and CI/CD automation. So in this phase focuses on understanding the full backend and cloud flow, from local deployment all the way to production-ready API running on my own domain. So I started by building the backend locally using fast API. This API accepts image or selfie uploads, runs a mock AI inference, and return structured results like season, body type, and confidence. As you can see, behind the scene is designed to later plug into real AI model. So this is the upload selfie code and the health check and the S3 DynamoDB. So at this stage, I'm focused on clean API design, validation, and predictable response. So I want to try it locally with my AWS. You can see the API successfully processed the request and return a JSON response with inference results. You can see is okay. Once the API worked locally, I containerized the application using Docker so it can run consistently anywhere. And this is the latest image I built. So in the Docker file, you have the base image, dependencies, the entry points, and this ensures the app behaves the same locally and in AWS. After verifying everything locally, I deployed the service to AWS manually, step by step, to fully understand the infrastructure. So I pushed the Docker image to Amazon ECL, which acts as the image registry for ECS. This is the latest image. Then in the Amazon ECS, I created an ECS cluster and service, then connected a task definition to the image in ECL. This is the service and the task is running, and this is the task definition. So in S3 bucket, I created an S3 bucket to store uploaded images. Like when a user uploads a selfie, it saves securely in S3 bucket. And the IAM, instead of using access keys, I configured an ECS tags IAM role. This role grants the container least privileged access to S3 and DynamoDB. No secrets in code and no environment keys. And the DynamoDB, I also created a Dynamo table to store inference results and metadata. So each upload generates a record containing the request ID, image URL, inference output, and timestamp. And the CloudWatch, for observability, logs and metrics are sent to CloudWatch so I can trace requests, errors, and performance. The CloudWatch. Then in the domain, finally I mapped everything to my custom domain using Route 53 and application load balancer. Then I routed the traffic that when a user type HTTP, it automatically redirects it to HTTPS. So the API is now accessible at my domain, marianslaws.online, and is secured. With everything live, I tested a backend in production. So I checked the health with my domain. The health check confirms the service is running and connected to AWS resources from and the Swagger in the docs. From here, I can upload an image directly. The image uploads to S3. Inference results are saved in DynamoDB, and logs appear in CloudWatch end to end. So we will check it out. Let's try it out now. Upload the file. Execute. So you see, it has been successfully uploaded to the S3. So let's go to AWS S3 and confirm. So here we confirm the image. So I'm trying to open the image so you can view the image I uploaded. Then DynamoDB for. Okay, we also check for the inference results. See it there. And also the RDS for the logs. Okay. This phase demonstrates my ability to design, containerize, deploy, secure, and operate a production-ready backend on AWS without automation to fully understand every moving part. In the next phase, I will show how I automated this entire setup using infrastructure as code with Terraform and CI/CD, turning this into a scalable, repeatable system. Thank you for watching. See you in my next video. Bye.